Hey, what's up? It's your old pal, Mr. Cook. We're going to work on the 3.5 worksheets, so the odd problems. And this one's going to be all about word problems. So word problems in rational expressions are kind of all over the place. We tend to go with just like a couple of different methods for solving these. If you even like read the problems, they're all kind of similar. Number 1, number 2, number 3, number 4, number 5, and number 6. All of these have to do with working, one person working at one rate, one person working at another rate, and then how they work together. The way that you solve these is always the same thing. So since I'm not doing the evens, I'll just write it up over here. The way that you do these work problems is the following. So let's just take this first example. It takes Maria 15 minutes to sweep a porch. Ryan can sweep the same porch in 10 minutes. If they work together, how long would it take? Well, one of them is working at one rate, one of them is working at the other rate. So you can think of it like this, just setting it up as different rates of time. So Maria can do one porch in 15 minutes. That's her rate that she's working at. And then Ryan can do one porch in 10 minutes. So if we add their two rates together, that should give, the amount of time it takes for them to work together. So in other words, they can do one porch in we don't know how many minutes together. So adding them together, so 0 minutes, or X minutes, sorry, not 0 minutes. Okay, so this is how you set up all of these problems, by the way. It's it doesn't matter what you're going to be working with. Like number 3 says, working alone. Stephanie can pick 40 bushels of apples in 12 hours. Yeah, who really cares how many bushels it is and all that kind of stuff? But it's just like a set amount, the way that these problems make sense is if you say that they're doing the same thing, essentially, the same work, the same process, painting a wall, painting a room, or maybe jogging 15 miles. It's always like the same distance or amount. So you can just say that it's one of those. So here's a real general way to write it out. And it works every time, by the way. If you just say 1 over one of the rates of time, so rate number 1 or rate A, let's say, plus 1 over the other rate that you get in there, rate B. I don't know. And this actually works for as many as you need. So you can add in rate C, rate D, rate F, whatever, however many rates that you have. And then it's equal to 1 over the rate that all of those work together. That's how it works. That's how the problems go. So, in setting up this one, it's 1 over 15, because that's Maria by herself, plus 1 over 10, because that's Ryan by himself. And then we'd want to solve for how well they do together. So that's how we just set up the problem. And this is a rational expression, so we just solve it using the same methods that we did before. We find a common denominator, multiply that across the top, and then simplify it and solve. So if you just take the denominators for all of these, 10 and 15 and x, if you multiply them together, that gives you a common denominator. It's not the most simplified one, but it works every time. So 10 times 15 is going to be 150. So 150x is a common denominator. So I'm going to multiply that onto everything here. So 150x, 150x, 150x. All right, and then, just write it out. So 150x times 10 times 1 is going to be 150x, and then that's over 15. And then 1 times 150x is 150x over 10. And then 150x times 1 is 150x, and then it's going to be over x. Now we can start simplifying a bunch of stuff. 150 divided by 15, that just turns into 10, so 10x plus. And then 150 divided by 10, that just knocks out the 0, so we just get 15x equals. And then 150x over x, the x's cancel, and we just have 150. All right, now combine like terms. 10x plus 15x is 25x. And then divide both sides by 25, and you get x is equal to, what is that, 6? Yeah, 6. So if Maria and Ryan work together in sweeping the porch, they're going to get it done in 6 minutes. So then just make sure you put your units on there and you're good to go. And that's how you do, these problems. So I'm going to use that same method for setting these up and do number 3 and number 5. 70 can pick 40 bushels. 40, that number is just sort of a distractor. You don't really actually need it. You just keep 1 in the denominator in the numerator for each of these. So you get 1 bushel of apples in 12 hours. And then one day her friend Castle, I don't know if that's a real name, whatever, Castle, helped her, and it only took 5.74 hours. So that's when they worked together. So that's actually going to be this X value where they work together. So plus Castle's rate, we don't know what it is equal to the rate that they work together. So 1 bushel of apples in 5.74 hours. So again, we just, put together the common denominator. So it's going to be 12 times X times 5.74. I don't like the decimals, so let's go ahead and multiply those together on our calculator. 12 times 5.74 is 68.88. So 68.88x is our common denominator. So we multiply that across the top and we get the following. 68.88x over 12 plus, and then 1 times 68.88x is 68.88x, and then that's over x now is equal to, and then 1 times 68.88 is 68.88x, and then over 5.74. Okay, now we just simplify this as much as possible. 68.88, if we use our calculator and divide that by 12, it comes out to a nice number that's familiar to us, which is 5.74, the number that we had, 5.74x plus 68.88x divided by x. The x's just cancel, and we have 68.88. And then 68.88 divided by 5.74. You can check on your calculator, but it's going to give you 12. So 12x, because the x is still there. All right, now let's solve this. So we're going to subtract 5.74x from both sides to see what we get. So 68.88 is equal to, let's use our calculator, 12 minus 5.74, 6.26. So 6.26x. Divide both sides by 6.26, and let's see what our x value is equal to. It's probably going to be a decimal, so I'll write about equal to. So 68.88 divided by 6.26, around about 11. So about 11 hours for her to get, the 40 bushels, or, whatever it is, apples or pears, or who gives a crap, for 40 bushels. All right, so about 11 hours. That's our answer, because we got 11.0032. Okay, number 5, let's set it up and solve it. So working alone, Wilbur can mop a warehouse in 12 hours, so 1 warehouse in 12 hours. Huang can mop up the same warehouse in 10, so that's plus 1 over 10 hours. How long would it take them to work together? So that's 1 over x. Just remember that the together one is the one that's by itself over here, and you should be able to do these problems pretty easily. All right, let's find the common denominator. So we have 12 and 10 and x. This is a common denominator of 120. If you want like the least common denominator, just find the smallest number that is in common between the coefficients. So 12 and x, that would actually be 60. So, you could use 60x also and it'll work, but, this is just a surefire way to get that common denominator. So I multiplied in the top on all these ones, and I get 120x over 12, plus, and then it's going to be 120x over 10 is equal to 120x over x. So I can divide out the 12 here, and I get 10x. I can divide out the 10 here, and I get 12x. And then I can divide out the x here, and I get 120. Combining like terms, 10x and 12x makes 22x. Dividing both sides by 22, I get x is equal to 120 over 22. And then I can reduce that a little bit. Let's see, these both divide by 2, so I get 60 over 11. And then that should be, an approximate answer for our solution. Let's see what we get. 60 divided by 11. And that's about 5.45. Okay, so 5.45. Then what? Hours. That's how long it took them to work together. And there's our little solution. All right, so that's the first 3 problems on 3.5. We're going to make a new video for the next one, which is going to be mixture problems. So we have 2 examples of those, so we'll probably do both of them. And then the distance problems. So probably do 1 video for those problems. All right, so that's it. Let's move on to the next side of the page.